Today we're doing a topic only, exclusively for grade 12s called calculus. Right? We're starting it off with the definition. I'm going to ask you, probably 1 million viewers watching, 2 million viewers. I don't know what's the viewership like. But if I ask all of you, what is the meaning of the word calculus? Many of you, 99% of you have done it in school. But if I ask you, what is the meaning of the word calculus? Bet you still can't tell me. The meaning of the word calculus means gradient. That's it. And if you understand this concept that the word calculus means gradient, the whole of calculus now falls into place. Why? Let me explain to you something. We know, to tell you, to put you into the picture as to what calculus is. You know, for a straight line graph, now forget about calculus. You have a straight line graph. We need to find the gradient of this. So we got A and we got B. So to find the gradient here, to find the m value, we all know from grade 11 and 12, we're going to say y2 minus y1 over x2 minus x1. There we go. That's it. But that is the gradient of a straight line. What about the gradient of, do we only have a straight line in this world? No, you've got an infinite number of graphs. So how then would you find the gradient of any other graph besides a straight line? Calculus. Calculus is the only way in which you will be able to find the gradient, or calculus deals with finding the gradient of any other graph besides a straight line. So the word calculus means gradient. The word derivative means gradient. The word differentiation means gradient. All these three mean the gradient. We are finding the gradient, but they are different processes. So, and the word first principles. One more, first principles. So the word first principles, derivative, differentiation, all deals with finding the gradient. First principles deals with finding the gradient using the formula, and that we will get to now. Derivative is using the shortcut or the power rule to find the gradient. Differentiation is for more complex. It's also finding the derivative for more complex graphs. So all these three mean exactly the same thing. Now, to make you understand, so many of you say, no, I don't believe you. What is the relationship between calculus and what is the relationship between y2 minus y1 over x2 minus x1? So we know the first question in calculus would be find the derivative by using first principles. We know what is the formula. What is the formula for first principles? F dash x. The general gradient, f prime x, f dash x. The general gradient on f of x is given by the limit as h approaches 0, f of x plus h minus f of x all over h. And that is your first principles formula. How is that derived? What relationship does y2 minus y1 over x2 minus x1 have with f of x plus h minus f of x all over h? And let me explain this to you. Watch and pay attention. Imagine, just imagine, you had a parabola and you had a secant. Now we know a secant touches at 2 points, a tangent touches at 1 point. Now, if this value here, say we didn't give you this value, right? You don't need to know this. This is just to expand your knowledge. It's just to put you into the picture as to what calculus is all about. I'm going through basics, assuming that you know absolutely nothing about calculus. So, if this value is x, its function value would be f of x. It's y value, because we know f of x represents y. If this distance between here and here is called h, right? This one's y value would be x plus h, and its y value would be f of x plus h, the function value of x plus h. So now, if we call this, so if we put it into coordinate form, then this must be x plus h, that's its x value, and its y value is f of x plus h, right? Let's just take all that out. And this one's x value is x, and its y value is f of x. So now we're just putting it into coordinate form. So if I call this x2, y2, and I call that x1, y1, and I want to find the gradient of the parabola, the average gradient. And what do we know about average gradient? y2 minus y1 over x2 minus x1. So let's go. Average gradient, the m value is equal to y2 minus y1 over x2 minus x1. What is y2? F of x plus h minus, what is y1? F of x over, what is x2? X plus h minus, what is x1? X. Now plus x minus x will cancel out. What do I notice? I get f of x plus h minus f of x all over h. Isn't that my calculus formula? And where did I get that calculus formula from? y2 minus y1 over x2 minus x1. So what I'm doing here is just proving to you that y2, the gradient, is given by that. Now m, we don't call it m anymore, we call it f dash x because that's your gradient. And why do we call it limit? Limit as h approaches 0. Very simple. We want to find out what is the maximum distance that secant can travel, because we always want 2 points, until it almost becomes a tangent. But it doesn't, because a tangent touches at 1 point. So the maximum distance that secant is going to travel until it almost becomes a tangent. So if the distance between here and here was 10, as it gets smaller, what's going to happen? As this line travels down, it's getting narrower and narrower and narrower. So the distance will be 10. 9, 8, 7, 6, 5, 4, 3, 2, 1. What number is it approaching? 0. So if we convert this formula into English, what would it state? It would state that the general gradient on f of x is given by the maximum distance that the secant will travel until it almost becomes a tangent in the simplified version of y2 minus y1 over x2 minus x1. There we go. If we converted that formula into English.